probably need the next set of slides. Good afternoon, my name's Suranjan Som, work for a company called IM Group, Information Management Group. Some formal slides coming up in a couple of seconds. But before I formally kick off the presentation, I guess all of you have been either playing around or talking about or looking at big data for quite a while. So I'd seriously be fooling myself if I were to believe that, I can talk about a business case. No, not this one. I can talk about a business case on big data which you're currently not aware of. So probably if I kind of position my presentation more as a corroboration of the fact that we're all kind of on the same page, probably reiterating facts which you already know, and maybe we might learn a few things either from myself or from yourself in more of an interactive session. So that's primarily what I've got on the agenda. 30-second intro, case study about a few customers of ours who are currently looking at big data, and also kind of trying to understand why we're doing big data now in particular. And then looking at what are the right reasons for developing a business case for big data, what kind of sponsorship should we look at in an organization, how to get the right team together, and probably tailing it off with why most people get their business cases wrong. But then we'll see how that goes. So a quick 30-second intro on IM Group, which you probably may have come across this morning in the Carl's session. But we were founded in 1999, about 13 years ago, headquartered in the City of London. Also got offices in Manchester and New York. We've got about approximately 200 staff right now, multiple award-winning Microsoft Gold partner, as well as partners with SAP and Oracle. And we're also identified by Gartner as a niche player in the information management space, and a fair amount of cross-sector experience, especially with specializations in investment and retail banking, media and retail. So I think that was less than 30 seconds. So let's get on to actually what we're talking about. Okay, so a quick case study with one of our customers. I can't identify the customer because of privacy reasons, but they are probably one of the largest media houses in the UK, as well as worldwide. They keep coming in the news all the time. That's probably a hint. They are seriously looking at big data right now. At the moment, they're managing their entire advertising process or advertising sales process, where all the ad sales information is either coming in straight through their points of sale or booking agents. It's coming in online and it's coming in through telephone orders. And what they're quite proactively trying to do is collect all that information and mash it up with market information that's coming in through social media channels, capture all that information in Hadoop clusters, combine that information into a traditional data warehouse, and then make that information available in a visualization layer and feed it back into their CRM system, so that the guy who's actually sitting on the telephone or in the store has access to all that information, which he's mined through all those processes and is able to give his customer a better deal. Now, which is great, and I think a lot of people are trying to do that. The interesting thing about this particular client is not only are they looking at kind of this combined paradigm, they're slowly trying to kind of take that entire traditional database piece completely away out of the equation and make the entire platform a big data platform. So they're currently running all their databases on Hadoop, or trying to make all their databases Hadoop, and do all the analytics using a product called Karmosphere Analyst, which I think is available on the Amazon Elastic MapReduce platform. Again, as I said, they are a very big name in the media space, and I was myself surprised when they said that they're actually trying to do that. Personally speaking, I'm still skeptical about the fact that you can actually take away the entire traditional database aspect out of it, because I think if we go to the next slide, I think this is what reality is looking like today, and this is our interpretation of where the market's headed, which is you have this this traditional space around data warehouses, which I think is still quite relevant and quite important for most organizations, regardless of, all the big data jargon that's going on. Most of what we're looking at is really big data warehousing rather than big data. I mean, when we're talking of big data, you're talking of seriously unstructured data which are being held in loosely structured data formats in this space here on the left. Whereas in most situations, regardless of the volume of data you're looking at, basically you're looking at a large data warehouse where, maybe yesterday you had a few million rows, today you have hundreds of millions of rows, maybe billions of rows. Most of the customers that we deal with, especially in the investment banking space, tens of billions of rows of data per day is normal. But then all the data is still structured because we know where it's coming from. We know it's coming from standard application systems. We know the formats, and therefore we know the structure it's going into. It's still a standard database feeding into a standard data warehouse and then being made available through standard visualization techniques. It's only in this space where you're dealing with unstructured social data, you're dealing with information like smart meter readings, you're dealing with API calls, you're dealing with you're dealing with things like market data feeds from places like Bloomberg and Reuters. That's where the true power of big data comes into play. And what we do believe is, at least for the next few years, probably next 10 years, we will see a lot of collaboration between these two spaces where you'll initially capture all your data through these kinds of from these kind of sources through big data, and you'll still have your traditional data warehouse, and you'll use some sort of a business abstraction layer to bring all the data together. Because at the end of the day, if you think about it, it's great to store lots of data, great to store lots of volumes of data, but what's important is, what do you do with the data? How do you make sense out of the data? And for that, contextualization of the data is very important, because it's great to say I've got 10 terabytes of data sitting somewhere, but what am I going to do with that data unless you can match it up with something that actually makes a business sense for you? So contextualizing your big data will allow you to actually harness true value out of your big data stores. And for that, you will be looking at, going forward, you'll be looking at lots of these hybrid paradigms where your data's coming in from your traditional stores, from your big data stores, but going through some sort of a business abstraction layer. We certainly do believe that this is happening quite a lot. This is great. This is all fine. The only issue with this is there is another big constraint or constant which is kind of associated with this. This does take a lot of time to develop. I mean, all of you who've come from a data warehouse type background or have dealt with data warehouses in the past, it's taken you anything from 6 months to several years to actually build a data warehouse. And that's another space where big data is beginning to play quite a significant role. Situations where you don't actually have the time to build a warehouse and do all these things, which is where you chuck in a lot of data into some sort of a loosely structured mass, and you basically throw a lot of people who understand the data at that mass, and you say, go figure out the problem. And that's another space where big data is making a big show. So regarding building a big data business case, I guess the key point is, do I have the right reasons for doing big data in the first place? So, one of the reasons for doing a big data, or some of the main reasons I would see in doing a big data implementation, would be, of course, beyond building a data warehouse. And now, obviously, if you've already got a data warehouse in place, you're not really building another business case for big data. It's probably kind of continuing from that. But in addition to having a data warehouse, by having a big data implementation in place, you can gain extra competitive advantage on top of what you have by, improving your processes even better. So, for instance, let's say if you're on a power organization or an electricity organization, you can actually now capture smart meter data from all of your meters out there much more quickly and much more accurately, integrate that as part of your overall billing process and make that happen much, much faster. You can obviously know your customers better and know their behavior better. And this is kind of, the whole kind of social media story. Not only are you looking at the transactional behavior of the customer, which is what people like Amazon have been doing for the last 15 years. Effectively what Amazon's been doing is looking at the transactional behavior and then determining what the customer is going to try to do next. What we're trying to say now is, beyond that transactional behavior, you're also looking at the social behavior of the customer by being able to link to the customer's social patterns, the kind of internet-based activity that the customer is doing, and being able to build a context around each of your customers. So therefore, adding personalization and contextualization on top of your customer's transactional behavior, which is allowing you to know your customers better, and it's allowing you to read your markets faster. Gone are the days when you would you would test launch a product in an unknown city and figure out, is this product going to actually last or not? These days, you can build a brand and kill a brand in about 15 minutes' time, just by the use of social media. So it's about understanding your markets and reading your markets faster. And of course, at the end of the day, it's also about reducing costs, and I'll go into that in a little more detail in the next slide. The other valid reason for doing big data, and again, most of you probably are already aware of this, and this is kind of just a reiteration, is for storing data for future analysis. Now, your organization may be involved in lots of different activities, and you might be collecting lots of different data from lots of different places, but not all of it might be relevant for you today. So if you're in the transport business, for instance, if you're TfL, TfL collects about, I think it's about 0.5 terabyte of Oyster card usage data every week. Now, the point is that data actually relevant? Will you need that data 2 years from now? What do I do with 150 terabytes of data every year? Do I really need it? And the answer right now is probably yes, probably no, but you don't know. But going forward, maybe in 5 years' time, you've got algorithms that are good enough and smart enough to actually get some proper trends and patterns out of their data. And for those situations, big data gives you a cheap and affordable way to store all this data for now. So you probably don't have a business case to say, what are you going to do with this data right now? But you're saying, just because I have this data, let me keep it. It's not going to cost me that much. Let me actually keep this data today. I'll analyze it tomorrow when I've got the appropriate tools and technologies to do so. And that's something which a lot of organizations are proactively doing today. So in order to understand that, the whole aspect of why is it cheap then, so we need to understand what exactly is big data. Because one of the reasons why a lot of people kind of get the business case wrong is half the people don't really understand what big data is. Most people think it's just building another big data warehouse. So big data basically is made up of two main things, or at least I think it's made up of two main things. There are lots of other things, of course, but primarily storage and computation. So you've got these huge clusters of things, or nodes, or whatever you call it, and in each of those nodes you've got a lot of CPU cores, and associated with each CPU core you've got direct attached storage. What that's giving you on the storage side is lots of distributed nodes of data with very cheap storage, and also at the same time something that's fault tolerant and reliable. And that kind of storage is at least up to 10 times cheaper than traditional SAN. So when I talk of some of our investment banking clients, and I know probably some of them are actually in this room, they are looking at big data right now, and they've got an approved business case for big data because they've said, we generate 66 terabytes of risk every week. And if I'm generating 66 terabytes of risk every week, and I want to store that information for a year, you go and ask for whatever that works out to, about 3 petabytes or whatever of SAN space, you'll need a seriously strong business case to support that. So they went to the business and they said, we understand you've got a policy of data storage, replication, this and that, tolerance, etc. So here's 5 petabytes of SAN space. It's going to cost you X billion. And by the way, we could also do it in big data. It's going to cost you X divided by 10 billion. It might not be as resilient as that one, but it's still a risk that otherwise we wouldn't have captured anyway. Can we go ahead? And guess what? They were given the business case, go ahead on that, because it was that times cheaper. And when you're talking of serious volumes of data, big data does give you a significant differential in costs. And if we're looking at the kind of at the pace at which technology is improving, the whole kind of aspect about fault tolerance, reliability, being able to do DR on big data, all those problems are being addressed eventually anyway. So, you wouldn't have the IT department in there or the governance department in there saying, sorry, you can't have big data anymore because you can't do DR on big data. So those problems are being addressed, and those challenges are being addressed anyway. And of course, the other aspect of big data, by the way, is the whole big compute thing. So with these thousands of nodes of data that you've actually now got thousands of extra CPUs or cores available out there to do lots of computing. It is, right now, a bit of a challenge to justify doing all sorts of computing on big data right now, because not all algorithms are fully parallelizable. Therefore, you can't go out there and say all my databases have to be a big data database, because all big data databases don't support full SQL, for instance. So you can't have a like-for-like database today, as yet. Going forward, you probably will have a lot. There are lots of algorithms being developed on big data architectures, data mining, fraud detection, pattern recognition, all of these things. They actually run much, much faster in a big compute environment than they would run on an SMP architecture. So you are looking at serious uses of big data on the compute side as well going forward. But right now, if you need a business case, you can see that the lowest hanging fruit probably is on the storage side. You can quite easily go out there and say, I want to store all of this. Can I actually go ahead? Okay, in terms of getting the mix right then, obviously, getting any project or program off the ground requires an appropriate mix of people, process, and technology. So technology a bit, I think we've kind of driven that to death now. In terms of the process, yes, you do need to ensure that you have a proper methodology, you have a proper set of best practices out there. So if you're actually kind of teaming up with a consultancy or teaming up with a set of individuals, do make sure that they understand what they're doing. Do make sure that they have some set of guidelines, because you are spending a significant amount of money anyway. So do make sure that something is in place so that you're not just kind of spending your money on just an experiment. And then, obviously, you need to make sure that you have the right people in the room. And that would involve, the first choice, obviously, would be the data management team in any large organization. They understand the data. They're dealing with the data day in, day out. And therefore, they would probably be the best facilitators for any kind of huge data management or data movement type exercise. In addition to that, if you're trying to, if you're generally attacking a big data problem, then it's usually a business problem. It is never a technology problem. And therefore, do make sure that you have the appropriate subject matter experts from the business side on that team, because otherwise you'll never ever get to any answers on that solution. And then, of course, an individual who's becoming very, very important in most of these big data assignments is, I guess, Darren, you call yourself a data scientist as well. And these are a breed of very special, coveted people. And I don't know if I've got any colleagues from EMC in the room today. But EMC, I think, is probably one of the bigger proponents of the data scientist concept, and quite truly so. These data scientists are people who understand data. They understand the underlying technologies that are involved in big data, so Java algorithms, Hadoop clusters, and all that kind of stuff. And they will usually be the people who you will entrust with a problem. So if you're TfL, you'll entrust one of your team of data scientists to say, here's my 0.5 terabyte worth of Oyster data every week. Just go and find out things that I want you to find out. And it's their job to usually do that. So it's a role which is becoming more and more predominantly important within most organizations. But of course, in addition to everyone else, you need to have the right sponsor. Now, any program, be it big data or data warehousing or any other technology program, at the end of the day, it involves a fair amount of business change. It involves a paradigm shift in the way the business is thinking about something, especially when there's so much money involved, if you're doing a large investment. And therefore, in order to drive that change within the organization, you need to make sure that there's someone loud enough and important enough in the organization to back your program. So, yeah, I mean, if preferably if it's someone from the C-level audience, then probably his or her voice will be heard the loudest. But if not, at least there has to be a big data champion within the organization who has enough authority to drive these messages through. And it's not just enough to say, okay, I've got the CEO who's the big data champion and therefore, carry on doing big data. You've got to ensure that if you're actually getting any success out of your big data program, even if it's like small bits of success, you communicate that success regularly to the organization, because that will, again, instill a lot of confidence in whatever you're doing. Because for most people, this whole big data initiative is something these data guys are doing in the back room. I mean, they probably don't appreciate what's going on. So being able to kind of demonstrate some tangible benefits out of any big data initiative will reinforce and reinstill vigor into that initiative and get the support from the business. So, if you want to build your big data story, I think the key thing is, get a clearly identifiable business case for it. Make sure that you're doing it for the right reasons. Communicate regularly, and try and do it one small step at a time. Don't try to say, I've got these 150 terabytes worth of data, let me trawl through all of it in one go and give you something back, because A, you won't be able to do it, and the business will lose faith in what you're doing. So try and identify a small piece within the business, a small area within the business where you think you'll be able to generate some immediate ROI straight away, and then build on that, review that, refine that, and evolve that. That will probably give you the best return for your buck. And of course, if you can't do it yourself, always you can get external help from people who are doing it. Hint, hint. And then my final slide around, so why do people get it wrong most of the time? I'm not sure if there's anyone in this room who's been rejected a business case on big data, but then again, this is kind of from collective material that I've trawled through everywhere to find. So, well, one of the reasons is very few people actually understand what the proposition is. So, as I said, most people will think a big data warehouse is big data, and therefore, get it wrong in the first step. And even if there's a technical audience who understand what big data is, most of the time they have a lot of difficulty in articulating that in business terms to the business audience. So while the guy who wants to do big data understands why he needs to do big data, the guy who will actually spend the money will not have a clue about why he's trying to do big data. So again, getting someone who knows what it is and can articulate what it is will obviously add a lot more value. Again, another key point is most organizations see big data as a pure technology project. Now, no project is a technology project, regardless of what people say. Starting from if you're building a CRM system to a data warehouse to a web application, no project ever has been a technology project. Every project is a business project because it's being done to help the business in one way or the other. And therefore, it's the same for a big data project. There's no such thing as a pure technology project, and you should make sure that big data doesn't get labeled as such. And as I said, most people try to do it all in one go. Don't try to boil the ocean. Do it one step at a time, one drop at a time. And then, last but not the least, sometimes in your organization you probably don't have enough data to justify it as a big data problem at all. I mean, if you're talking about a few million rows of data, that is not big data. If you're talking about big data, you're talking of real volume, real velocity, and real variety of data, which is going into billions of rows, going into very complex structures. That's when you are in the realm of big data. So if you're within a few million rows, don't even think you've got a big data problem. It's not a big data problem. Well, for me, I think that's about it. Thank you very, very much for your time. If you've got any questions, I think now's the time. Well, thank you then.